Okay. Today what we're going to be looking at are the Pythagorean identities. Those of you that took pre-calc, these should look familiar to you. Okay. At least the first one. All right, so on your note sheet, we're just going to write those out. Sine squared theta plus cosine squared theta equals 1. Please be aware that these only work if it's squared. Okay? So you can't just say sine plus cosine is 1. It has to be sine squared. They're Pythagorean identities, which are like Pythagorean theorem, okay? Where it's a squared plus b squared equals c squared. You can't just say a plus b equals c. It doesn't work like that. Okay, so these, and on your formula sheet, why don't you write above this, only work if squared. Right above that box. Or you don't have a box in yours, do you? Put a box around it. Because those will only work if they're squared. All right, now the other one we'll put on our notes. We're just copying from the formula sheet. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals secant squared. Now when I took pre-calc, I had memorized these. You in advanced algebra do not. I came up with like weird ways to remember. Yeah. I still remember that. Okay. Now, if I didn't confuse you enough, get ready to be confused. So I told you these ones only work if squared. These ones will work if squared also. You can square those ones. The other ones only work if squared. The other trig identities, you can either square them or leave them regular. So what this means is that if I were to tell you sine squared theta, write that in an equivalent form, you can tack on a squared here, and that is an equivalent identity. So this would be equal to 1 over cosecant squared theta. So all of the trig identities that we talked about so far work for squared. All right, now, these are the only 3 that are written on your formula sheet. Based on these, you can come up with 6 additional formulas by rearranging things around so that they're in different formats. And I highly recommend that you write these on your formula sheet. Okay, can I erase this? All right, so on your formula sheet, right next to where this is, we're going to write several equivalent forms, maybe. Just by using inverse operations. Okay. You can solve this Pythagorean identity for a different variable besides, right now it's solved set equal to 1. We could solve this for sine squared. What would I need to do to both sides to solve for sine squared? If I want to get sine squared by itself, how can I move the cosine squared to the other side? Kara?
You just subtract it?
Yes. So if you subtract cosine squared on both sides, you will get that sine squared theta equals 1 minus cosine squared theta. Again, you want to add these to your formula sheet. You also could go back to the original one, but solve it for cosine squared this time. You would subtract sine squared on both sides. So you'll get cosine squared theta equals 1 minus sine squared theta. Now the reason I'm telling you to add these is because it'll be a lot easier for you. If you see on your problem 1 minus cosine squared, you'll know it's the sine squared without having to rearrange this formula every time. It'll be right visibly easy for you to see. All right, let's do the same thing for the other formulas. Okay, this is our plane identity, but we could move the tangent squared over. So we would get 1 equals secant squared theta minus tangent squared theta. What's the other way I could rearrange that identity?
Tan squared theta equals 1 minus, or
Subtract 1 on both sides.
secant squared theta minus 1.
Good. So you could subtract 1 on both sides instead. And then the last one, again, we'll come up with 2 additional for that one. Who thinks they could give me one identity that would be rewritten from the original? Either moving the 1 over or moving the cotangent squared over. Someone I haven't heard from in a while. Anyone besides Kara? Looks like you're writing them, so you know them. You share them. Julian?
1 equals cosecant.
Yes. Cosecant?
Cosecant theta minus cosecant.
Good. Okay, make sure you have your squares on there. I'm sure you do. And then what would the other one be? If I want to leave the cotangent squared, I would have to do what with the 1? Subtract it. So we'll get cotangent squared theta equals cosecant squared theta minus 1. Again, theta stands for any angle. Could be 70 degrees, could be 5 or 6. All right, so having these on your paper will actually save you from having to do work on a lot of the problems because you'll just be able to look and see. Remember, it goes both ways. So if you see this on your paper, you'll know it equals 1. You don't have to always see what's on the right is equal to the left. The left is also equal to the right, so you can go both directions. We'll wait until everyone has these done. Same thing applies today as we did yesterday. We want to make sure the angles match before we start. Some of them do, some of them don't. All right, so check our angles, 90, 90, good to go. Okay. Now, when you see sine squared, again, use your context clues about like what you're looking for on your formula sheet. I see sine squared plus something, so immediately my eye is drawn to this formula. And I'm wondering, is there any way that I could change the 1 over secant squared to be the cosine? Okay, so let's see if we could change this. All right, so 1 over secant, let's go find that. 1 over secant is equal to the cosine. So 1 over secant squared will be equal to the cosine squared. So in your notes, let's jot that down. Cosine theta equals 1 over secant. Therefore, cosine squared will equal 1 over secant squared. Again, on your homework, you don't have to show this work, but for your notes, so you understand like what we were looking at the formula sheet. So because 1 over secant squared is equal to the cosine squared, we can get rid of this and change it to be cosine squared 90. And then what is sine squared 90 plus cosine squared 90 going to be? 1. Okay, the next one actually doesn't require any work if you look at your sheet. The ones we added by hand. What is secant squared theta minus tangent squared theta equal to? 1. On your handwritten formulas, you should have 1 equals secant squared theta minus tangent squared theta. So just realize you can go backwards looking at the other side. So the answer is just 1. Now, if you didn't have those written on your formula sheet, because you weren't listening to me, you could actually rewrite secant squared 28 equal to 1 plus tangent squared, and then minus tangent squared, and then those would cancel and you'd still get 1. But obviously, the handwritten formulas, we have no work to show. You just look. Okay. All right, let's start making it a little bit more. Oh no, this one still has the same angles. 20, 20, and 20. Now, notice we have no squares, right? Nothing is squared, which means you are not looking at those formulas anymore because nothing's squared. So we're only focusing on the other ones. Who has a suggestion? This is actually a problem we did yesterday or something similar to it. What should I change? Haley? The sine over cosine. You could also change the tangent, just so you realize. It doesn't matter which one you do. Haley said this one. So we go to our formula sheet, we find out that sine over cosine is equal to the tangent. So this becomes tan 20. What is tan 20 minus tan 20? 0. Now, just an alternate method, if you don't like that, you can change the tangent of 20 to equal sine 20 over cosine 20. And then leave that one as it was, and you would still get 0. So you guys might get the same answer but have different work depending on how you do it. Okay? Make sure you're not changing both of them. Okay, some students they'll change this to sine over cosine, then they'll change this to tangent. Like you want them to look alike. Okay, sometimes you do have to change both. Rarely, but. All right, got a big problem here. What's our big problem? Angles are not the same. So again, if you didn't add this to your sheet, these are used to change angles. Again, the more you do this, the easier it's going to get. It doesn't matter which one you change. I'll just change the bottom one. But again, it does not matter. So we go to our sheet. The cosine of theta equals the sine of 90 minus theta. It's always going to be the number that's in the other expression. But if you want to check 90 minus 55, this will be the sine of 35. So we have sine 35 over sine 35, which will be what? 1. Just like if I had 5 over 5. 5 divided by 5 is 1. Sine 35 divided by sine 35 is 1. Some students will cross them out and tell me the answer is 0 because they're like, nothing's left. But that's not true. There's always like a 1 hanging out in front. D. I see the secant and cosecant, I see a subtraction. You start thinking about these, but remember, they don't have squares, so you can't use them. Okay, which one do you want to change, 28 or 62? 28, okay? Secant equals cosecant of 90 minus theta. So this will be 90 minus 28, which will get me cosecant of 62. Leave the other one alone. Don't change it. What do I get when I subtract? Cosecant 62 minus cosecant 62? 0. Nothing. Try E on your own, and then we're going to flip to the back. We're only going to do C on the back, because the other ones are all, what will we be getting for E? In front. 1. Angles matched. Changed one of these to the other one. Doesn't matter. I think I changed cosecant to 1 over sine. Leave the other one as is. Cancels out to get me 1. Alright, I said we'll skip over A and B here. Go to C. What do we notice as a problem to start off? Angles don't match. Again, you want to convert either the 35s all to 55s or the 55s to 35s, doesn't matter. Let's do the 35s, just because they came first. So again, we go to our formulas for complementary angles. Cosine is equal to sine of 90 minus that number. So this will be equal to sine of 55. What do you think I'll get when I multiply? Because these are being multiplied. Sine 55 times sine 55. Yes. Now, make sure you don't think it's 2. Think back to algebra. X plus x is 2x. But x times x is x squared. So think about these like variables. Sine 55 times sine 55 will be sine squared. Now, there's 2 ways to write it. The squared usually goes above the sine, not the 55, because otherwise you might think it's 55 squared. Or if you want, you could also write it like this, parentheses. That's more writing. Okay. Sorry. Sine 55, quantity squared. All right. change the sine 35 over here. That will be equal to cosine of 90 minus 35. So that'll be cosine of 55. So I have cosine times cosine, which will be cosine squared. And cosine squared, or sine squared plus cosine squared equals 1, using our identity over here. Whoa. All right, that's the last one we needed to do. All of the rest were just extra practice, things that we've already touched upon either yesterday or today. Homework is the back of